Hello there, everyone. For our formal proposal presentation, we're going to go over the case for reinstatement of net metering for DTE electric customers. This presentation is prepared by Aaron Cruz, Chad Gavin, Mordecai Bronfen, and myself, Yazin Alarov. So to start us off, we're going to have a little introduction. So roughly 5 weeks ago, our group formed to undertake research efforts required to draft a formal proposal. This proposal is regarding the reinstatement of the net metering program from DTE. So our group is composed of 4 people: Aaron, Chad, Mordecai, and myself, Yazin. So part of our project required us to have tasks that would be assigned to group members. So our group identified 4 main jobs and 1 administrative role. So these jobs were assigned to members based on qualifications. And the 5 jobs that we came up with were a project manager, a researcher, a media editor, a writer, and a text editor. So based on the qualifications that we'll go over in further slides, we came up with the following task assignments. So Aaron was assigned as our group's researcher. Chad was assigned as our group's media editor. Mordecai was assigned as our group's project manager and as our text editor. And myself, I was assigned to be our group's writer. So in this slide, we'll basically cover the descriptions of the following tasks that were mentioned in the previous slides. So for the project management role, it basically ensures the timely completion of predefined deliverables by the set time frame. So our group used proven project management tools, including Gantt charts, email, and cloud collaboration. So the project manager basically ensures that everything is being completed and we're using the correct tools. The researcher role assumes ownership of identifying and compiling and proposing valid and usable research using online tools, the utility websites, published articles, and dialogue with a group subject matter expert. So moving forward from the previous slide, in this slide we're basically going to continue covering the tasks that our group has. So starting with the media editor, the media editing role provides media creation, editing, and publishing using a professional video editing software. So the text editing role basically ensures that the grammar and mechanics of group literature is composed professionally and correctly. And the writing role ensures that all the idea, research, and media is composed into reports and easy to understand literature. So this slide is really important because it goes over our members' credentials. So starting with Aaron, his qualifications include organizational skills, Microsoft Office proficiency, and research proficiency. So moving along, Chad has experience with Adobe Premiere Pro, and he's currently undertaking a role as a support engineer intern. Moving along, Mordecai's qualifications include Microsoft Office proficiency, knowledge of correct grammar usage and mechanics. He's currently employed by DTE as a software engineer intern. So my qualifications include Microsoft Office proficiency, knowledge of video recording using Microsoft Office, teamwork and collaboration. And I'm currently employed in a sales role for a major telecommunications company. So in the next slide, Mordecai is going to introduce the actual proposal.
Hello everyone, this is Mordecai Bronfen. I will be presenting the proposed program part of our final presentation. So we did some research on how much electricity DTE Electric produces in a year. So it turns out they produce about 42 million megawatt hours of electricity annually. So actually the majority is produced from coal. So this is actually a chart put out by DTE. So we could see that in 2017, the capacity of coal was over 6,000 megawatt hours. So actually, in accordance with Public Act 295, which is mandated by Michigan Public Service Commission, 3.6 million megawatt hours, or 8.5% of electricity, was produced from renewables in 2017. And I actually calculated this from the chart below. So this figure will progress to 10% in 2018, 12.5% in 2019, and eventually 15% in 2020. And then obviously that's until further legislation is passed. So obviously this proliferation of renewable energy associates a inverse correlation with carbon dioxide emissions. So we take a look at this chart right here. So DTE actually does not produce all of its power by itself. This is own generation. So we can see that the total own generation of carbon dioxide emissions for 2017 was about 29 million. In 2018, it's projected to be 29 million as well. And then if we take a look at own generations plus purchase power, so it's about 34,000 in 2017, and then 32,000 in 2018. So we obviously see that number going down. So by the end of 2018, all of DTE's almost 2 million customers will be equipped with a bidirectional smart meter. So this is an AMI meter, advanced meter infrastructure, which can measure electricity being pumped to the grid and being pumped from the grid. So this meter obviously saves a lot of energy and is equipped for net metering. So given that every DTE energy customer will be equipped with this new bidirectional meter, so the Michigan Public Service Commission allows for up to 1% of renewable energy to be sourced from net metering. So as of now, the figures are significantly lower, which is about 0.02% or 22,000 kilowatt hours. So compared to other renewable energy sources, net metering and solar power in general are currently not a significant source of renewable energy. However, this is slowly changing. The amount of net metering customers is steadily increasing, and we can see this in the upward concavity of this graph. So in 2006, we had about few net metering customers. Then that figure doubles in 2017, doubles in 2018. 2008, and 2009 it also skyrockets, and then eventually we compare 2006 and 2016 when it's about maybe 100 to over 2,500 customers. So given like this upward slope of the graph, we could see that in 2017 we'll see an increase, in 2018 we'll see an increase, and eventually net metering will be a reliable source of renewable energy. So as the awareness of reliable energy continues to increase, more customers will install alternative energy apparatuses, whether that be solar or wind or whatever it is. The amount of energy pumped back into the grid will exponentiate. In just a few years, net metering can actually produce 1% of DTE's renewable energy. This 1% limit set forth by the Michigan Public Service Commission will gradually increase in positive correlation with renewable energy production standards. So ultimately, DTE will be able to produce a portion of its renewable energy from net metering by outsourcing key infrastructure requirements to the customer. And this will enable them to concentrate investment on an aging electrical grid. So I hope that this presentation has been informative, and I will hand it over to Aaron, who will produce the budget/fiscal considerations portion.
Thank you, Mordecai. And hello, my name is Aaron Cruz. I'm going to be talking about the fiscal consideration for our proposal. For the budget, there really isn't that much of a cost to DTE. This is because our proposal basically is arguing for DTE to revert back from an inflow-outflow distribution generation tariff back to the actual net metering program that they had in place before. Now, there are going to be changes in costs between DTE and the consumer, but these aren't actually laid out yet, and it's kind of hard to say what those prices will be or the differences. So what I did instead was I wanted to actually look at the differences in technologies between DTE solution and the actual consumer solution for generating energy and clean energy. So to look at the future of DTE and green energy, their main plan is all about wind and wind farms. So DTE, they are planning on spending about 1.5 billion in renewable energy in wind in the future. And I just wanted to paint a scope of the actual amount of work that goes into building just one turbine. So these wind turbines are 479 feet high. They are over 300 tons of concrete and steel. They require a pretty large amount of land, not for the actual perimeter of the wind turbine, but for regulation and code, it needs to be on a large amount of land. And then this carries over into the idea of land contracts. This is usually done so with farmers who already have a large amount of land. And then there's data collection that needs to be done because we obviously want wind turbines to be in an ideal place where there's going to be a lot of wind generated. Then they need to build service roads. They need personnel for research and continued maintenance after the machines are constructed. And then there's also the shipping of these large blades and materials via huge semi-trucks, large boats, etc. And during the construction of the wind turbines, DTE stated that it could take up to 6 large cranes as well. So it's a huge endeavor to build these wind turbines. And obviously it costs a lot of money as well. So what I wanted to do was I broke down a project that DTE had done in between 2012 and 2014. Now, one of the first areas that DTE started expanding their wind farm growth is around the thumb of Michigan. I guess this is a very good area for wind. So as you can see on this map here, there's a lot of wind turbines in this area. So they built about 140 turbines, and it cost about $500 million. So we're looking at about $3.6 million per turbine. So I looked at the amount of energy that each turbine could produce, and I figured out how many houses this could potentially power. So when I looked at it's the U.S. Energy Information Administration, they estimated about over 10,000, almost 11,000 kilowatts per hour is needed for an average household. So I averaged that to 11 megawatts per hour. So if you divided the output of the 140 turbines that they were producing by the 11 megawatts per hour, you're getting roughly about 45,000 homes that these 140 turbines would power. So that's for $500 million. So then I went ahead and I wanted to consider how much money this might cost on the consumer end. Obviously, the consumer would most likely use solar panels to create energy for their home, renewable energy. And so typically, there's a large range of models for solar panels, but I looked at one of the more typical ones is 250 watts. So on average, they say we get about 4 hours of consistent sunlight a day. So if you take 250 watts times 4 hours, you got 1 kilowatt per hour. So to enable to produce 11 megawatts of power, the equivalent to powering a house through the wind turbine solution, you would need about for this estimate, 44 solar panels per house. So if you break this down, I found one of the first listings I looked for solar panels. They were running for about $219 per panel. So if you multiply that times 44, you're going to get a price of $9,636. So I went ahead and multiplied that times the 45,000 homes that we estimated the wind turbines could power, and we have a price of about it's estimated to about $434 million. Now this is cheaper than the wind turbine solution. And obviously there's a lot of differences between these estimates. Obviously the wind turbines, they can work theoretically all day long, as opposed to the solar panel only be able to work for 4 hours a day. And then you have other things like longevity. It's possible that the wind turbines could have a longer lifespan than the solar panels. I know from some of the solar panels I was looking at, I saw things like stating 30-year warranties. So I don't know what the lifespan of the wind turbine is estimated at. But the difference between the two solutions is about an 87% difference. So the solar solution is actually only 87% of the cost of the wind turbine solution. So this tells me that the solar solution at least is significant, and that if we really want to be serious about creating renewable energy infrastructure as much as possible, that we should keep things like the net metering in place that's going to highly incentivize customers to take part in the program, as opposed to coming down on with lower tariffs, etc. Next, Chad will be talking about the conclusion of our project.
Thank you, Aaron, for the introduction. Hello, everyone. My name is Chad Gabon, and I'm just going to be going over the conclusion of our formal proposal. Essentially, what I'm going to be doing is just summarizing the material that each team member covered in today's presentation, and kind of review some of the solutions and recommendations that our proposal offers. So starting with Yazan, he gave us the introduction of today's proposal. He basically went through the role of each team member and what we've been doing to move forward throughout this project. Where Mordecai, he was assigned the project manager and text editor role. Aaron has been doing the bulk of our research. Yazan is the writer, doing the majority of the writing for documents, and I am the media editor, where I'm consolidating everyone's presentation and combining them in software, video editing software. Yazan went on to kind of give us the qualifications of each member. Mordecai is a DTE software engineer intern, so he's able to kind of communicate with the company directly and talk to people there for primary research. Aaron is heavily research proficient and is able to consolidate usable research that he finds on internet or in published documents and stuff like that. Yazan is working as in telecommunication sales, and myself, I'm an engineering support intern. Mordecai then gave us the proposed program, basically the bulk of our proposal and what solutions our team has for this issue. The main overall goal is for us to have DTE reinstate net metering for several different reasons, which have been talked about during our projects. Mordecai pointed out with research that renewable energy correlates inversely with carbon dioxide emissions. So as we produce more energy using solar panels or wind, carbon dioxide levels are contained and lowered. After a little bit more calculations, Mordecai also found out that about 8.5% of DTE's energy produced in 2017 was produced from renewable energy. Obviously, with programs like net metering, we're able to increase that percentage by giving an incentive, a better incentive for customers and consumers to provide this energy. Mordecai also was talking about by the end of 2018 or by 2019, all 2 million of DTE's customers will have a meter capable of net metering, which is good and actually sets up a basic infrastructure that will allow this program to take place. Another good thing is that DTE can outsource this energy production to consumers. So that means no overhead cost for them. They don't have to purchase anything. Basically, they're just allowing their consumers to get paid the full retail rate by producing solar energy, and all they have to do is change their policy. The MPSC set, our goal actually is to have set a 1% limit on renewable energy and gradually increase that as solar power and wind power get more popular. Then we have Aaron, who went through some of the budget and fiscal considerations. Aaron first points out that because of our proposal reinstating the reinstatement of net metering, essentially is all on the customer side for purchasing. So DTE really sees they have limited concern with their budget in this regard because it's just simply a policy change. The infrastructure and all the cost is outsourced and is paid for by the customers. So Aaron went on to kind of just give us a rundown and kind of comparison of wind energy or wind farms versus solar energy. And Aaron actually found out that home solar production is about 13% cheaper than wind farms. So DTE is investing a lot of money into building wind farms, which takes a lot of material costs. You have all sort of land contracts you have to do. They're putting in roads just to service these wind farms, and the list goes on, where you're racking up a lot of money. However, if you look at what consumers will pay to install solar panels onto their house or in their backyard, it actually ends up being cheaper per amount of energy that is produced. This ultimately means we need to encourage the development and growth of solar energy through programs like net metering, which give a good incentive or a better incentive for customers to actually produce clean energy on their own. And as always, thank you guys for listening today. Feel free to contact us with any questions or feedback. We appreciate any sort of insight that anyone can give, as this is a project that is very important, and ultimately with very little change from DTE on their end, they could make a big difference in Michigan's economy and environment. Again, here we have listed our emails, and feel free to reach out if needed. Thank you guys again for listening. You all have a wonderful day.